All right, today we're going to get into welding technology. I know, it might sound super industrial, but it's this powerful and honestly pretty invisible force that literally holds our modern world together. No, really, just take a second. Look at your chair, think about your car, the building you're in right now. What is stopping all of that from just falling apart? Well, you might be surprised to hear it. It all comes down to just a few basic ways we join materials together. So, on the most basic level, you've got fastening. Think screws, bolts, nails, stuff that physically holds things in place. Then there's bonding. This is all about using some kind of adhesive, like glue, to stick two surfaces to each other. Simple enough? And then you have welding. And this is something else entirely. It's not just about holding or sticking. It's about making separate pieces literally become one. So, in a world full of glues and screws, what is it that makes welding so different, so unique? Let's dive in. The whole secret lies in one really powerful word: fusion. See, welding is the art of causing fusion. It's a process where you're not just connecting things, you're basically rewriting their story on a molecular level. You're turning two separate pieces of metal into a single, unified whole. This comparison right here makes it super clear. With bonding, you're using a third thing, an adhesive, to stick two surfaces together. But with fusion, you're actually melting the base materials themselves, letting them flow together and then cool down as one single continuous piece. It's kind of like the difference between taping two pages of a book together versus those pages being printed on a single sheet of paper from the very start. Okay, so how in the world do you create enough heat to literally melt metal? Well, for most modern welding, the answer is inside something called the electric arc. That's right. The whole thing kicks off with a really controlled, high-energy spark. And this isn't just any old spark. It's the very specific catalyst that unleashes the crazy amount of power you need to achieve fusion. And that brings us to the two big workhorses of the industry: MIG and TIG welding. Now, they both use an electric arc, but their techniques are for totally different jobs. You can think of MIG, that's metal inert gas, as like a hot glue gun for metal. It feeds a wire continuously, which makes it super fast and perfect for production lines. TIG, tungsten inert gas, that's more like a fine point pen. It's slower, yeah, and it definitely takes more skill, but it gives you this incredible precision for really detailed or delicate work. So now that we kind of get the basic ideas, let's look at the anatomy of an actual weld. How do you go from two separate hunks of metal to one solid, unbreakable joint? The whole process is this really fascinating dance. First, you strike the arc, creating that intense heat. That's your spark. This instantly melts the base metal, and it forms what's called a weld pool. Now, into this little molten pool, you often add a filler material to give it more strength and volume. But, and this is critical, the whole operation has to be protected from the air by a shield of gas, otherwise it gets contaminated. And finally, as it all cools down and solidifies, you're left with a permanent joint and a seam. The actual physical proof that two things have truly become one. The absolute key to this whole thing is the electrode. That's the part that carries the current to the metal, creating that super important arc. And in a pretty clever piece of engineering, with a process like MIG welding, the electrode is also the filler metal. So it's literally melting directly into the joint as it does its job. But working with this kind of energy, it's not simple. The very thing that makes welding so powerful, all that heat, also creates its biggest challenges. I mean, we are talking about temperatures that are just hard to wrap your head around, often over 6,000 degrees Fahrenheit or 3,000 Celsius. That is hot enough to melt steel in an instant. And while that extreme heat is what you need for fusion, it also puts the metals under an incredible amount of stress. And that brings us to the welder's greatest enemy, really: distortion. When you rapidly heat metal up and then cool it down, it expands and contracts. That causes it to warp, to bend, and to pull out of shape. So a huge part of a welder's skill isn't just joining metal. It's mastering the art of controlling and even predicting that distortion. Right, so the ultimate goal is always a perfect, strong bond. But if that distortion isn't controlled, or if the weld isn't totally clean, you can end up with a weak joint that needs to be repaired. Welding is just as much about fixing imperfections as it is about creating new things from scratch. But here's the thing: welding isn't always the right tool for every single job. And to really appreciate its power, you've got to understand where it fits in with the whole extended family of joining methods. So besides welding, you've got other options like brazing and soldering, which are kind of its closest cousins. Then you have the mechanical methods like riveting, and of course the chemical methods using an adhesive. Each one has its own place. This table lays out the key differences perfectly. Welding is in a league of its own with those incredibly high temperatures that actually melt the base metals. That's true fusion. Brazing and soldering, on the other hand, they work at much lower temperatures. They melt a filler metal that basically acts like a super strong glue. But, and this is key, they never actually melt the pieces they're joining. So, the big takeaway here is this. Welding is fusion, while its relatives rely on bonding. So, when you boil it all down, the story of welding is a journey. It all starts with a single spark, which ignites an arc, creates a molten pool of metal, and then solidifies into a permanent seam. And it does all of that for one reason, to create unparalleled strength through fusion. So next time you see a welded seam on a building or a bridge, just remember that incredible power of fusion. It kind of leaves you with a thought, doesn't it? If the absolute strongest bonds in metal are created not by adding something between them, but by fundamentally merging them into something new and stronger, what could that teach us about building connections elsewhere in our lives?